Hi, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome my friend Stephen Wilson. He's an adjunct professor at the University of Queensland in Brisbane, Australia. Well, Stephen, good day to you.
Good day to you, Robert. It's great to be on the Power Hungry Podcast.
Well, thanks. It's evening here. It's morning there. I've warned you that guests on this podcast introduce themselves. So if you don't mind, please imagine you have about a minute. You've arrived somewhere and you're introducing yourself to people you don't know. Please.
Well, Robert, I often jokingly introduce myself to students as engineers think of me as an economist and economists think of me as an engineer. I started off studying engineering back in the day, mechanical engineering, and then I went into energy efficiency consulting, and my career, it wasn't planned this way, but it's just turned out this way. I've sort of moved from the customer end all the way up to the upstream resources, and so that might seem like going backwards, but there's an old joke about electricity being a commodity that moves backwards at the speed of light. So I've actually followed the electrons
backwards,
moving against the energy flow and following the electrons.
Electricity is a commodity that flows backward toward the speed of light.
Backwards at the speed of light. It's an old joke from a British engineer. So, yeah. So anyway, I've worked from energy efficiency back up through the networks and generation and transmission and network economics, and then into gas, and on a journey that took me from Melbourne, Australia, to Hong Kong, to London, and I've worked in about 30 countries around the world, and I've covered basically all forms of energy, electricity, gas, and the upstream primary fuels, and then into the mining industry. I did a stint of about 5 years with a big mining company covering coal and uranium and getting my head around nuclear and of course renewable energy policy and climate change and all those issues. So and then in more recent years, I became an academic for a few years. I was a full-time professor at UQ, and now I'm an adjunct professor and working on technology development, commercialization of new energy technologies in the startup space, as well as doing advisory work.
Gotcha. Well, I want to talk about your recent report. It came out December of 2021 on nuclear in Australia. But we'd corresponded, and we have several mutual friends in common. Patrick Gibbons among them, and Tristan Prasser, and I think Ben Hurd, and other Australians who are interested in energy policy and particularly in nuclear. So I want to talk about your nuclear research paper and what's going to be needed for Australia to kind of break out of where it's been for a long time, in particularly so coal reliant. But tell me what's happening with the electric grid in Australia. I've been following it for some time. Your prices have been skyrocketing. What the hell's going on?
Yeah, so the main grid, so careful saying the grid, we've actually got several. Right. We're such a big country with such a small population, thinly spread. We've actually got a few electricity systems in Australia. But the main one,
and they're not interconnected, is that right? Or
the main one is interconnected. So it's basically the Eastern Australian grid. So it spans the eastern seaboard. So it wraps around more or less following the coast. From South Australia, Adelaide, South Australia, and then round through Melbourne and Canberra, Sydney, and then up through Brisbane and up the Queensland coast. And then the small system in Tasmania is connected by a submarine DC cable. So that, when people say the National Electricity Market, or the NEM for short, that's the physical system they're talking about.
I see. And then Perth and Western Australia is all separate then, not interconnected.
Perth, so there's a thing called the Southwest Interconnected System, or SWIS, which is the much smaller grid around the city of Perth in Western Australia. And then there's a Northwest Interconnected System, which is a small grid around the iron ore mining towns in the Pilbara region. I see. And then there's another small system in the Northern Territory, Darwin-Katherine Interconnected System, and then across the vast interior, there's what I call a constellation of small diesel remote systems.
Right. Gotcha. Okay.
Yeah. Well, and sprinklings of renewables throughout here. Yeah.
Right. So then bring us up to speed, because I've been reading about skyrocketing electricity prices. Your wholesale prices in earlier this year were up something like 100 and some odd % over a year ago.
Yeah.
You have abundant coal. Is this a reflection of higher coal prices? What's driving these electricity prices so much higher in Australia?
Yeah, there's actually a lot of factors in play, Robert. But so on that big Eastern Australian grid, we have a competitive market. Overlaid on the physical system is a competitive market system, which is based on is something that's fundamentally the same as the original so-called gross pool system in the UK. So an energy-only wholesale spot market is the core design feature of that market. It's the market, the details of the market rules have evolved and continue to evolve at a breathtaking pace. But that's fundamentally what the market is. Around that core of the spot market, there's a number of other markets that where people trade other services and products. But that's the core of it. And the price is, under the rules in place, the price is allowed to move up to over 15,000 Australian dollars per megawatt hour on a 5-minute spot basis, and it can also go down to minus $1,000 per megawatt hour. So what we've seen historically, that market, that spot market, tended to clear around the short-run marginal cost of generation, and so if you plot the data historically, what you would see is something that looked very much like the short-run marginal cost curve. Mm-hmm. And that's basically a textbook competitive electricity market of the type described by Schweppe and the guys at MIT in their classic book back in the late 1980s. And that's sort of the basis for the design. But
so if you don't mind, I'm sorry to interrupt, but if you don't mind, just explain that just a little bit, because I'm getting better at understanding electricity markets, but they're all incredibly complex, as you just referenced. So, explain the cost curve. You're saying that the cost of the fuel then would set the price. Then is that? Did I follow you there?
So what economists in their jargon call the short-run marginal cost is how much does it cost you to supply the last little bit that exactly satisfies the demand at that moment.
Right. So
okay,
that last watt, or if you're going to be talking about an energy, the watt hour, right?
Yeah. At the bulk wholesale level, it'll be the last megawatt hour.
Okay. Gotcha.
So what does it cost to produce that last megawatt hour?
Right.
And so that's how the market design is designed to reveal that through the price mechanism.
Okay, gotcha.
That's the basic philosophy. And so, as you said, we've got a lot of coal in Australia. We've got a lot of physical coal, a huge amount of physical coal in the ground, but also our generation system is dominated in the eastern states by 16 large coal-fired power plants still, which are aging. They're getting older. Most of them were built in the 80s and 90s. So, but we've also got some hydro in the Snowy Mountains,
right?
The big hydros in the Snowy Mountains between Sydney and Melbourne, and we've got an increasing amount of wind and solar,
right?
And we've also got gas. We've got a lot of gas in the ground. We're one of the world's largest exporters of liquefied natural gas, and gas plays a crucial balancing role in the electricity grid. It's kind of the go-to fuel to physically balance the system and to balance fluctuations. Historically, you'd be balancing fluctuations in demand, but now you're balancing both demand fluctuation and renewable energy generation fluctuation.
So no different than other countries, especially the U.S., where you were balancing renewables with natural gas primarily.
Yeah, well, so there's an element of that here in Australia as well, but it's not on the same scale as the US, of course.
Right.
Yeah. So so there's a lot of factors in the dynamic at the moment with high prices. One of them is extremely high international gas prices.
Right.
Another one is extremely high international export coal prices. So those factors are having some influence on what's going on in the market in Australia. We've seen our gas spot prices go extremely high.
On what per gigajoule or million BTUs? What are you talking about there?
Well, they went high enough and cumulatively for long enough to trigger a price cap coming into effect in the gas market at $40 a gigajoule is a cap. So
right.
The shadow price behind that at times was, I think, $800.
So if it had been allowed to float, you're saying it would have gone to 800 if there was unrestrained.
Yeah, that's what the shadow price is supposedly signaling. But yeah, prices basically got this very tight spot market, and finding it extremely hard to clear, and prices just going astronomically high, and then the cap gets triggered under the rules at $40. And then
so the gas is priced at a what sounds like an artificially low number, but the spread between what would be the spark spread between turning that gas into electricity would be much. I mean, at $40 gas, you could still make a lot of money at $15,000 a megawatt hour, right?
Well, yes, except what happened in the electricity market is the electricity market also has what's called a cumulative price cap. So if the 5-minute spot prices added up over the space of 7 days are above a certain trigger level, then what happens is a cap gets triggered in the electricity market, and that number in the electricity market is $300 a megawatt hour. So you can have a 5-minute $15,000 price. You can have quite a few of them, but if it stays at high levels, not necessarily even anywhere near 15,000, if it stays bouncing up and down at high levels for long enough, then this cap gets triggered, and then bang, automatically the price is fixed at $300 for a period of time.
I see.
So that occurred, but at the same time in the background, gas is at $40, and then there was a whole lot of generators who couldn't turn $40 gas into $300 electricity, and then they said, okay, we need to withdraw capacity because otherwise we'll just be losing money. Yeah, and
so they quit participating in the market.
Well, they rebid, right? In effect, withdrew capacity from the market, and then we found ourselves in a situation where there were a whole lot of manual directions. Was becoming very hard to physically balance the market, because remember, you've got generators bidding to meet demand, and you've got a computer model that's matching those bids to the demand at the lowest overall clearing price. But you've also got to take into account all the transmission constraints and all those things in the physical network as well, and make sure it's actually going to work and going to flow properly. And then there were all these manual instructions being given, and then they got to the point where the dispatch engine, which is the computer model that works out which generators should run to produce the lowest price, the dispatch engine couldn't solve the dispatch for a number of intervals of the coming day. And at that point, the CEO of the market operator, the AEMO, Australian Energy Markets Operator, who is also the system operator,
right,
he made an executive decision, exercised one of the obscure powers under the rules that had never been used before, and just said, I'm suspending the market. We're just going to manually dispatch all the generators just like in the old days. And that order was in place for a week or two, I believe.
Well, so as I hear you saying this, Stephen, I can't help but think the ERCOT nodal market protocols, the model, the rules that govern it, it's 1,800 pages long, right? I mean, it just seems like
okay. So you've got the silver medal, I think. I thought our rules were,
and you have the gold medal.
No, we have the bronze. The national electricity, the detailed rules that run the electricity market. Last time I checked, it was, I think, 1,736 pages, something like that.
Well, so who wins the gold medal here?
PJM, I heard the other day, is at 4,000 pages. So They've won by the length of the straight, right? So more than the length of the straight. So so these market rules, it's not just that they're long and complex. Last time I checked, they're in version 181. For the last 2 or 3 years, they've been changing the rules on average about every 2 weeks.
Mm.
So imagine if we change the road rules every 2 weeks. So I don't think there's anyone who could honestly claim to fully understand the entirety of the rules. There's a body that's job is simply to review and update and change the rules. It's a sort of a growth industry. So that's the world we're in.
Well, so as you're saying this, Stephen, and we've talked about this before offline, but it was what we discussed was how Australia, the UK, now Texas, California, they've fallen all in a similar kind of rut, I guess would be the right word, that this idea, we're going to have this kind of competitive market, but the consumer gets screwed. I'll just do a quick vignette. 20 years ago, I was writing my book on Enron, right? That was my first book. And as I was researching it, I was one of the guys who was he worked for Houston Natural Gas before the company he changed its name. And he just in passing said, well, I think this whole deregulation of the electric market, it's bad for the consumer. And here we are now 20 years later on that. It seems that this conceit, and I think that's the right word, that we can let the market decide how to govern this most critical energy network. It just isn't working. And because as I hear you talk about this, it's just failing because of the possibility of manipulation, but also that the complexity of the system becomes so extreme that it just can't work right. Am I off base here?
I partly agree with what you've said there.
Okay, well, tell me where I'm wrong, and well, tell me what we're in the same church here, right? I'm in the wrong pew. Tell me where.
I like the church analogy because there's this thing. Yeah, there's this thing that's sort of the faith in the market, belief system,
right?
And what I've been saying for probably 5 or 6 years now is that there's this idea that you can just leave electricity to the market,
right?
The idea, you use the word conceit, and it feels like you're channeling Hayek with the fatal conceit, which was of course his critique of communism or socialism. That there was a sort of fatal conceit at the heart of that. And of course, what we're talking about is like the opposite, almost like the opposite extreme of a state-owned, centrally planned, socialist, if you like, electricity system.
Right.
We're talking about supposedly laissez-faire, completely free market electricity system. I say supposedly because it never really was that. But so there's this belief of the 1990s economists, which I think in a way was a sort of an overreaction against socialism or communism or those ways of thinking. It's almost an overreaction to the opposite extreme. And the way I think of it is this idea that, look, all you have to do is pass a well-drafted, well-written Electricity Act in the Parliament, and then you put in place, underneath that act, you put in place a set of technical rules, this is the thousands of pages of rules we were just talking about.
Right.
Put in place a good set of, technically robust rules, and you have some sort of regulatory supervision from like a competition authority or some form of regulator, and you have an independent market and system and market operator, or an ISO or a TSO or an RTO in the American jargon. Right. And then, congratulations, politicians, you'll never have to worry about electricity ever again. Because you just leave it to the market.
Because the market is going to sort it all out.
That's the 1990s sort of strong belief, the sort of the church of electricity free markets. And the thing is, no one really believes it anymore, as far as I can see. They're sort of still going to church, but they don't believe it anymore. And so what went wrong is a good question I think we should ask ourselves. What went wrong along the way? And your question was implying that it was always doomed to fail. I'm not sure that that's the case. The problem is that we started running this experiment in the 1990s, and then we didn't let it run long enough. Like to see if this experiment is really going to work, you'd have to let it run for longer than the life of the assets. So you'd need to let it run you'd need to let it run unimpeded for like at least probably 25, 30 years at least, right? Through a sort of a whole asset cycle.
Right.
And then, because the big skepticism about markets was always about, okay, so you'll get operational efficiency in the sort of 5 minute, the half hour or the 5 minute dispatch.
Mm-hmm.
But will you get investment efficiency? Will you really get the right investment in the right place at the right time of the right type or not? And the skeptics always deeply doubted that, right? But we never let that experiment.
And if I can interrupt, because that's the key issue. I mean, we see it here in ERCOT, and I just looked at their numbers, so that there's been no new gas-fired generation built in ERCOT in 20 years. We have the same amount of thermal generation in the ERCOT system as we did 20 years ago. Meanwhile, because of these massive subsidies for wind and solar, the amount of wind and solar on the ERCOT grid will exceed, by the end of next year, will exceed the amount of gas-fired generation. So So
that,
but you can't build, but bankers won't lend on new gas-fired generation because they can't be sure that they'll make any money. So I'm just following up on, because I think that's a critical, that's a good example of what you're talking about.
Yeah, these are great questions, and if I can just sort of take that apart, I think there's several issues there. So one is the bankability issue.
Right.
Bankers will or won't do certain things.
They want to be paid back. They're so selfish that way.
They like a certain amount of certainty, Robert.
Yes.
Understandably. And then the other issue, you've mentioned gas-fired generation, you mentioned renewables, and you mentioned the amount of each that's been built, almost all renewables and basically no gas. And you can see similar patterns in Australia and other places. Now, that the question of what type of generation is the investment going into, that's an interesting and important question. But in and of itself, you can't just look at a system and say, oh, they're only building this one type, therefore there must be a problem. Because if you look at historically at most power systems, what you'll see is that at any given moment, and by moment I mean like an entire decade or maybe 2 decades, at any given moment you'll find a system will tend to be investing in just one kind of generation. Like there'll be this big surge of investment in hydro. Like the original Snowy scheme in Australia, sort of they started building, I think, in 1947 and they finished that in 1974. So there's a big sort of surge of hydro capacity coming on sort of in one big period of time. And then you see other periods of time where it's all coal, or like in France in the 70s, it's like all nuclear, or like the dash for gas in the UK, it's like all gas. So what you've been in Texas, we've been in the same thing here in Australia for the last about a decade plus, sort of since about 2010-ish, 2010, 11-ish. Right. We've just been building wind and solar. That's it, basically.
Right.
And so what I would say is that's just a typical pattern in any electricity system, that at this moment in time, there's this sweet spot where that's the thing that made sense. Like when you sort of compare it all, so that's where the money goes.
Right.
And the mistake people are making is they're saying, oh, okay, so we found this sort of magic forever solution, and all we'll ever build forever now is wind and solar and a bit of storage. And all you need to do is have a bit of historical context, and you say, well, that's probably not true. It's gonna saturate, it's gonna reach its limit.
Right.
And I think what we're seeing in the market with the price volatility that we're seeing. So apart from your issue you're raising about price level, which is a real problem at the moment.
Right.
There's also an underlying problem of price volatility, which has been observable in our market for at least half a decade. And you can see very clearly that extreme volatility is driven by wind and solar volatility. And it links back to your point about the bankers, which is that the price, no one can produce a price forecast of this market. This is a quote directly from one of the most experienced bankers we talked to 5 years ago when we interviewed all of them about these related issues. So you can't bank a power plant on the basis of a spot price forecast in Australia,
because there's no certainty on or visibility into the capacity factor for the plant, and therefore whether that money, that loan will be paid back. Is that what you're going to? Where you're going?
Fundamentally, that's right. And the price formation mechanism is it's not working the way it was designed and intended to work under the original market design, right? So it's designed to signal the marginal price, and when the market gets tight, to signal scarcity and encourage new investment. But when you build a system that's got a high to very high share of wind and solar, the price mechanism starts signaling scarcity and abundance, but on a wildly volatile 5-minute basis.
Well, it's interesting. I follow you now. That's interesting, because one of the things I published on this recently was that you can see it in the ERCOT data that as demand has been peaking here, it's been very hot in Texas, as you probably heard. I know it gets hot in Australia as well, but very hot this summer. And when on these hot days, the wind almost goes in some cases almost to zero as the system starts to peak. So and we see it in Europe, where power prices are fluctuating based on how much the wind is blowing. So we've got this incredible system, development where the entire marketplace is dependent on the weather, which that to me is, well, wait a minute, if we're facing more extreme weather due to climate change, why the hell are we making our most important network depend on the weather? Am I misunderstanding this, Stephen? I don't think this is that complex, is it? That's a fundamental part of the problem, and the fatal conceit that you alluded to earlier, that you can leave everything to the market, is that you can distill all this complexity into a very simple price signal. But the problem is, if you engineer a system that's dominated by weather-dependent renewable energy, you end up with a system where nothing and no one has the power, if you will, the authority in control language, right? The control authority is lacking. So there's this screaming loud price signal coming out, and there's nothing and no one with the authority, with the physical, the machinery that's got the capability to respond to that price signal. And so that's why I've been saying for years now, we are testing this market to destruction. And you know what happens? You go into the lab and do a destructive testing program, by definition, you keep testing till you destroy it. That's what we're doing. And consumers are going to pay the bill.
Oh, yeah. Well, there's no one else, is there?
I was interested, too, in your thought, because it hadn't occurred to me that this reaction against the monopoly utilities system, right? That was this idea, particularly in the U.S., I think about, we trust markets, but you talked about that idea about the faith in the market. What did you say? That the faith in the market was a reaction to socialism and the end of communism, that now we're going to show, I thought that's fascinating, because I was looking up that famous Lenin quote, which was something like, communism is Soviet ideology and plus electrification, or something like that, right? That this was right. But Lenin understood that electrification was key to the strength of the nation, is the way I read that speech that he gave, right? But I guess here's my question: the point that I hear you getting to, or maybe the point that I think we're coming to together, is the system just doesn't have accountability. That at the end of the day, the buck doesn't stop anywhere. That there's no backstop. There's no one who ultimately is responsible to make sure the damn thing works. Is that
one of the problems. And so part of the sort of over faithfulness in Adam Smith, if you like, when it comes to electricity markets, is the idea that you don't need to worry about security of supply, and security of supply and reliability will largely take care of themselves as a byproduct of these market forces and the incentive that investors have, and so on. So that is an issue, and I think we're discovering that in a few places, including Australia at the moment.
Well, and as I recall, you said that renewables, neither renewables nor nuclear, can work in or will function well in these we're calling them deregulated markets, but I don't even know that's, or you call them competitive markets. But am I recalling that correctly? Did you say it that way, or what? I want to get to the nuclear part of this, but what effect in these attempts to have competitive market? Are they just ultimately doomed to fail? And how does the fuel? How do they affect the fuel mix?
Yeah, I think definitely renewable energy doesn't really fit within the competitive market. So I think that this is related to what we were talking about earlier, that, the investment cycle, the sort of long multi-decadal investment cycle. So it was almost like no sooner had we implemented these markets based on this very strong faith in the role that economic forces can play. We can just leave it to the market belief view. No sooner had we done that than we started violating our own faith, let's say, by subsidizing renewable energy into the system, right?
Right.
It's like, well, if you're going to leave it to the market, then you shouldn't be subsidizing things. And if you're subsidizing things, you shouldn't be leaving it to the market. So I think there's a deep incompatibility between renewables and markets, and I think it's revealed in the decision to subsidize. And in Australia, we do that in a very tricky way, where we hide the subsidy in a way that ordinary people can't really see that there's a subsidy going on. But the subsidies are huge.
How is it hidden, Stephen? How is that subsidy hidden?
So the renewable energy target creates a market in pieces of paper, and the legal obligation to buy those certificates, those pieces of paper, creates a whole lot of complex cross subsidies between the haves and the have-nots, if you will.
On the generation side.
Well, no, I mean, those who have rooftop solar and those who invest in wind and solar farms,
right.
But so it's the subsidies are sort of flowing internal to the electricity system. It's not like someone's sitting in the government writing checks to subsidize things. There's a little bit of that, but that's not the main game.
I see. Yeah. Whereas here in the U.S., those tax credits are coming from the federal government largely, and those are the incentives that are queering the market in terms of the investment, because the wind and solar providers, the wind and solar project developers, they're after those federal tax credits, and they're not responsible for affordability, reliability, or anything else.
Yeah. So the financial pipe, the channel that it happens through in the US is the tax system. Warren Buffett said that we only build these wind farms through the production tax credits. That's the only reason we do it.
Oh yes, I'm well familiar. Yeah. Yes,
but it's a production tax credit, so you only get it if you're producing. So if you produce a megawatt hour, you generate a megawatt hour of electricity from your wind farm or your solar farm, then you collect the credit. And so at that level, the mechanism is the same as in Australia. It's only if your wind farm generates the megawatt hour that it gets the certificate.
Right.
So that's a strong similarity. And that drives some pretty interesting bidding behavior, because it turns out, when you work the logic through, it turns out that the logical bid for those assets is actually right at the bottom. It's at the minus 1,000 level, in order to ensure they get dispatched. So if there's a constraint anywhere, you don't want to be the guy who bid 999 and the guy next door bid 1,000 and you got constrained off, right? So they all, as a herd, go and bid the floor price, but then they hope like crazy that someone else elsewhere in the system is setting a much higher price, and hopefully a positive number. If the market starts clearing at minus 1,000, then they all start trying to withdraw those bids. It's very unstable. Yeah. So
how do you solve this, Stephen? I mean, it just seems like a complete and utter mess, and then it's being exacerbated by these fluctuating fuel prices. You mentioned coal price. I'll just interject that the Newcastle marker, which is for thermal coal out of the Newcastle port in Australia, didn't check it today, but it's been around $370. It was $50 at the beginning of 2020. So we've seen a nearly 8-fold increase. I mean, which is just enormous. And
so those kind of coal prices are a reflection of the short global market that's been triggered by the Russia-Ukraine war, right? So the high dependence of Europe on Russian gas. Well, Russia is a big gas producer, and it's also a non-trivial coal producer,
right?
And the West is basically trying to, in very, very short order, stop using Russian gas. And then Russia's also, playing a slight game of withholding as well. That's the fundamental thing that's driven gas prices to these astronomical levels. And then, of course, you get a lot of gas to coal switching, the opposite of what people usually talk about. So which puts pressure on the coal market. And the coal market is configured in a way that it doesn't have huge amounts of spare capacity just sitting around. So the international seaborne traded coal price goes to extreme. Where these are extreme levels. When thermal coal goes above metallurgical coal, which is a tragedy because people start putting the good steel making coal in the boilers to generate power. The markets are extremely tight, and at these kind of levels, just astronomically tight. So some of our Australian coal generation has exposure to internationally traded coal prices, but a lot of it's actually not really exposed to those prices. It's just on a mine mouth. So all the lignite plants in Victoria are on mine mouth supply, not exposed to those prices. And there's also
So they're mine mouth. So the utility, the generator owns the mine, so they're not affected by these. These prices.
That's right.
I got you.
It's a captive supply at a very low cost, and some of the black coal, the power plants using black coal are also on mine mouth supply that's not exposed to export prices. But there is some exposure to those prices in some parts of the system.
Well, and one of the things that I thought was interesting about Australia, and I've been there twice and loved it. It's just an amazing country, and the people are all incredibly friendly. It's like a but your internal gas market is very constrained. And as I recall, when I was there was even talk about bringing LNG into Sydney because you couldn't get enough pipe capacity to provide enough gas in different parts of the eastern coast of Australia. Is that due to the difficulty of building gas pipelines? Why is that?
It's size and scale and distance. I spent 8 years in London, a lot of time working on European gas, and they have serious, like in America, you've got a big gas system, and in Europe there's places where you've got 10, 56-inch pipes running from Russia towards Europe.
Right.
It's just enormous, and we've got big long pipes from gas fields to cities that are 24 inches or something, 124-inch pipe, this kind of thing. It's just so relative to the American system and the European system, the Australian pipeline gas system is like this tiny little toy, right? It's very small, right? It's long and skinny, and the West Coast is completely separate from the East Coast. There's no pipeline interconnection because you've got a vast continent to cross, thousands of kilometers. Are you really going to build a skinny little pipe across there? Just you do the numbers, doesn't make sense.
Sure.
So on the economics, you would probably pull LNG from one side to the other, but there's with trading and other mechanisms, there's probably smarter ways than of doing it than that. But so you've got this small, relatively small physical pipeline gas system in Eastern Australia that used to be completely isolated, not just from the Western Australian export market, but from the whole world. And then when the Queensland coal seam gas was developed and the LNG terminals on Curtis Island, just beside Gladstone, were developed, we then became connected with the Asian LNG market. And then so then we're exposed to like Tokyo Bay netback pricing. In other words, what's the price in Tokyo minus the shipping cost and the liquefaction cost? That should be, in theory, the price in Australia.
I see.
And that's what when the competition regulator thinks there's problems, that's what they look at, right? It's like, are you charging your domestic customers more than the Japanese price minus shipping and liquefaction? Why is that? That's the kind of question the competition guy will ask. The big gas companies, but it's more complicated than that, because of course the LNG customers in Asia have written long-term contracts for their gas. They've written a 20 or 25-year contract, probably linked to the price of crude oil.
Right.
Whereas the domestic industrial customers, they're not writing 20 and 25-year contracts. They'll be nervous to write a 5-year contract.
I got you.
So the big gas companies tell these guys, well, you can't expect, you're not signing a long-term contract. How can you expect the same sort of price terms?
Sure.
And then people say, well, but we're Australian and this is our gas, and you should make sure we have enough. Right?
And after they stop laughing, they say, yeah, that's funny. Well, so you worked at Rio Tinto and we're very familiar with the global coal markets. And we talked a little bit about that price, but I've written about the surge in demand for coal in China and India together, increase of 700 million tons. I forget which one is it, 300 million increase, the other's 400 million. And these are just massive numbers. And so I'll ask the question this way. Why has coal been such a durable fuel? I mean, here we are 140 years after Edison used it on Pearl Street, and yet it's still accounting for 36, 38% of global electricity generation. Why?
Well, it's cheap gigajoules. I mean, $100 per ton high quality coal is like $4 a gigajoule or something. It's cheap energy. There's no question.
And a gigajoule, just for Americans, that's roughly equal to 1 million BTUs. So I was looking at Henry Hub today. Prices was at $8.70 or something like that. So you're saying $100 per ton for thermal coal out of Newcastle, high quality would roughly equal $4 per MMBTU, something like that.
It's that kind of zone. Yeah, that's right. So so it's cheap energy, and like in China, it's what they've got, right?
Right.
So, security of, if you've got a fuel right there under your feet, you're not having to import it. You're not at risk of blockades or any other issues. Sanctions,
currencies fluctuations,
whatever. Yeah, you've got it. It's there. It's under your feet. You just have to mine it. That's security of supply, right? So it ticks the economic box, and it ticks the security of supply box. And in the old days, if you could just scrub up the emissions, get rid of any sulfur emissions, SOx and NOx and those things, which you can do with technology, then you can be happy about the environment. But of course, the problem now is CO2 is very difficult to deal with.
Sure.
So coal sort of gets a sort of red cross in the environment box, but a nice green tick in the cost and the security of supply boxes.
Right.
So that's basically why we use a lot of coal. Well, why China and India and Australia indeed use a lot of coal.
So is that going to end anytime soon? I mean, you did a forecasting with Rio Tinto. You've been looking at this for a while. Is this? It seems that. Well, let me ask it this way: the inflection is the Russia invasion of Ukraine an inflection point in how these hydrocarbons are seen and how the energy security of supply dynamics change? How enduring is this going to be? Can you speak to that? You've got a Ukraine flag on your desk back there behind you, which is one of the other reasons why I think this is germane.
I was given that Ukrainian flag by a professor colleague of mine who's Ukrainian at UQ, and I do like to keep it there and remind myself every day of what the Ukrainians are doing, for all of us actually. But so coal it's very, very hard. It's much harder than people appreciate to get coal out of the global mix. Because of its characteristics, because of the attractiveness of coal to the people that are using coal, and because of the relative unattractiveness of the alternatives. The alternatives tend to be more expensive. The alternatives tend to reduce your security of supply, or make it even more expensive in order to achieve the same security of supply without coal in China and without coal in India. It's even more, makes life even more expensive.
Right.
So this is just the reality. And when we looked at this, a decade ago, we did some pretty serious scenario work and some, pretty rigorous modeling work around that. That was one of the findings that just was really clear in the results, is just how hard it is to get coal out of the system. And
so it's going to stick around for a while.
I think so. I mean, it's people might not like it, but that's the most realistic view of the future. I have to say. You do the numbers. I gave a talk. Gosh, it's about a decade ago. I think it was 2013 at the Australian Institute of Energy conference in Sydney. Just sort of explaining the China energy system to people. And the amount of investment even back then was clear that they were putting into nuclear. Huge industrial development program.
Right.
National sovereign capability, technology, designs. Plants. They're building a really big nuclear program, no question about it. Very steady, very patient. And, with visions, there was an official once said, we might have 500 gigawatts by 2050. I don't think they'll be at that level, but, it's going to be big. China will have the largest nuclear fleet. It will overtake France, and it will overtake the US, and it will have the largest nuclear fleet in the world. And I said to people, so you might be thinking, wow, it'll be like some kind of Asian version of France, 70% nuclear. Like, no, just to get China to, this is what I was saying in 2013, just to get to like 15% nuclear is really hard work.
Right.
It's just the scale of the country.
Because the scale of the country is so large.
It's just the scale. Yeah.
Sure. Well, so let's talk about nuclear, because I read through your December report, and it was that was published by UQ, University of Queensland, and it was the caption on it was, "What would be required for nuclear energy plants to be operating in Australia from the 2030s?" And you wrote that the country needs to commence a national public-private program of work as outlined, define the roles the Australian government will play. And then you concluded a natural next step is for the government to sponsor a scoping study on deployment and then infrastructure suitable for SMRs. Wasted issues. You still have to overcome some bans on nuclear that are internal to the different states in Australia. Is nuclear going to make headway now? I think we've seen the beginnings of a renaissance here in the U.S. We've seen it especially after Russia's invasion of Ukraine, Poland, Romania, the U.K. announcing ambitious ideas. Is this an inflection point? Is Australia going to finally get on the nuclear? I hate to say bandwagon, but make progress on nuclear now? Do you think?
Yeah, I'm going to be cheeky and rephrase your question. Are we going to get serious? And I think the answer is we are. All the polling, Robert, shows that slightly more than half of the population already is in favour of nuclear energy. Like the only thing I said in that report was that the minimum we need to do, which we must do, is we must seriously consider this, and we must start preparing real options. Like, not sit around having a theoretic academic debate, but actually do the preparatory work so that when we get to, say, 2030, the late 2020s, 2030, we've got a real option that we can actually deploy if we so choose as a nation collectively. It's a collective decision.
Right.
But it's no point having an academic discussion. And it's not just state government bans. There are bans in federal legislation that will need to be removed. But the way that our study sponsor, Mr. Barry Murphy, a UQ alumnus, former CEO of Caltech's Asia Pacific, by the way.
Right.
He understands, the role that nuclear can play, and probably should play in the Australian energy system. And we need to do that preparatory work. It's not just remove the bans and we'll magically have, nuclear power plants popping up. That's the least of it. I was on an expert panel in Adelaide last week, and I said that when we remove the ban, it'd be just like removing a splinter at the end of a long day's hike. There's a lot of hard work ahead, and that's just one small part of it. But yeah, I think. But
you have bans. You have bans in the states of Victoria, New South Wales, Queensland, and the Commonwealth, right? Which is where Canberra is, right? So, and then you said the first three major tasks are detailed review of existing legislation institutions, analysis of gaps in regulatory capacity, and work on repealing the bans. But it seems like this was, I won't say no-brainer, but this would be an obvious choice for Australia, given huge uranium resources. You've got a strong and stable government. You have the intellectual capital and universities that can help support the development of the mental and intellectual infrastructure that you're going to need, right, to make all this happen. But I'm going to say, well, it's damn well get on with it, right? This seems like the obvious thing, regardless of whether CO2 is your first, second, or third priority. This is, I think, the obvious way to go if we're serious about long-term stable electricity prices. But let's go back to how would nuclear work in this, I'm going to say, mess of an electricity market system that you set up. Can it work in that kind of system without a strong hand of government?
Nuclear can't work in this kind of market mess that we've got, right?
Cannot work.
No, I don't think so. I don't think so. No. And when you talk to the renewable energy totalitarians, right? So if you're a person who says we need 100% wind and 100% solar, then congratulations. By definition, you're a totalitarian. Okay, you're saying the totality of the energy should come from the wind and the sun, right?
Right.
So if you talk to the wind and the solar totalitarians, you know what you say, what about nuclear, guys? And they don't literally say this, but the feeling you get is they go, no, we've got a ban and there's nothing you can do. Right. And then it's like, oh yeah, and we've got this market that makes it impossible for nuclear power plants. Okay.
Yeah, too bad, yeah. Right? Yeah.
And with that, you get used to the blackouts, get used to the astronomically high prices, and wait for the political backlash, guys. That's the world we're in, Robert.
Well, so then what's the way forward then? I mean, you've outlined these potential steps, but the public acceptance is going to be one of the first jobs, right? And I think there has been all around the world and I think I can see it here in the U.S. The polling has changed, that there is much more public acceptance around nuclear. Is it going to? Well, walk me through those. You've listed a whole bunch of things, but give me the, items 1, 2, and 3 then.
Well, it's a dual reform process. So we whether we like it or not, I think we are facing another big reform of the electricity market. Mm. The subsidization of wind and solar has destroyed the 1990s pure market theory, right? It hasn't completely destroyed it yet, but it's well on the way, and it will completely destroy it. So that part of the conceit of the economist is this idea that you could create a market for renewables and it'd be compatible with the market for electrons, and it's not. So that there's got to be a program of reform happen there anyway, whatever we do. And then if we're serious and we really want to decarbonize our electricity system, we need to understand that the system's just not going to work as a decarbonized system if it doesn't have the right amount of nuclear in the mix.
Right.
I don't think it's going to work technically. It's definitely not going to work economically, and I don't think it's going to work politically. People just won't accept low reliability and astronomically high prices. Why would they?
Right.
I mean, the middle class will be okay, right? The middle class will go and buy diesel backup generators.
Yeah. Which is what we're seeing here. It's natural gas generally fired generators, but I just wrote a piece on what's good for Generac is bad for America, which they build 3/4 of the home standby generators, but their sales are booming. I mean, absolutely booming.
Yeah, and I think we'll see the same here. I've actually, it's on my list, Robert.
For your own home, for your personal residence.
We had the electrician in yesterday installing a fan or something, and I said, can you give me a quote to install a backup generator? Yeah.
And what is that going to be roughly? How much do you think it'll cost you?
They're not that expensive, but I think, I better get on it now that I'm saying it on your podcast, because I reckon we'll get to the situation there'll be none left in the shops. Yeah.
But here in the U.S., a friend of mine in Houston, she's buying a 20 kilowatt system. It's going to be 12,000 American, right? That's a lot of dollars.
Yeah. If you want a system that can run a big American house, it's going to be big and expensive. If you want something that can just keep the fridge cold and make sure the food doesn't go off in a 24 or 48 hour blackout, then it's, that's probably closer to $1,000.
Right. Yeah. Okay.
It depends what you want. Yeah.
Fair enough. A couple of quick things. So I've been to UQ. I think Chris Grieg, who's worked there, and he invited me. I gave a presentation there back in 2016, and I came across this paper by Simon Bartlett, who you may know, and he wrote this rather remarkable, very short paper called "The Pressure Cooker Effect of Intermittent Renewable Generation in Power Systems." And it just seems that this has it's so short and so kind of to the point that it's remarkable, but it brings to mind a comment that there was a guy named Ben Fouke, who is now the outgoing CEO, or the former CEO of Xcel Energy, which is a big utility here in the U.S. And he testified before the Senate. He said, as you add more renewables, prices go up and affordability goes down. I mean, and they're investing hugely in renewables. But Bartlett's thing says He says this in this pressure cooker paper. He says the scale up of intermittent renewables not only diminishes the robustness of a particular power system, but can also magnify the short and long term risk of investing in non-renewable generation assets and the power grid itself. I mean,
that's right.
What a robust sentence that is. I mean, there's just so much that it's describing about the dynamics and things we've just been talking about here. Is Bartlett still publishing on these issues?
I don't know whether Simon's publishing, he'll still be saying the same thing. It was, what year was that? Can you remember? It was
2016.
2016. Yeah. So any experienced power system engineer, with a sprinkling of grey hair and worth his salt will tell you the same thing. So what I find is that, the more experience people have when I say these things, the more they agree and tell me I'm not, there's also this and this, and you didn't mention that. It's like, yeah, I know. This is the issue, and we're seeing it in the research that I'm involved with on lots of different topic areas. We're seeing this same problem becoming very, very clear in the research findings from all sorts of different perspectives.
Well, and also in different geographies, as we've been talking about in the UK. In Australia, in Texas, in California, that the results are the same, and that as you add more renewables, the affordability goes down, reliability problems increase, but I think it takes the thing that I think renewables have is that they have this very positive kind of political. Press, right? That a lot of people just like the idea of wind and solar, right? That's just the case.
I call it the romantic poetry of renewable energy.
The romantic poetry of like that.
That's why Robert, that's why I fell in love with renewable energy when I was 15.
Right.
I was totally in love. I mean, I was so in love with it. I didn't like anything with moving parts either, Like if there was a moving part that could break down, I didn't like that. So I liked the passive solar home. I liked the Trom wall and all these things. I find them to be so beautiful and so wonderful and so elegant.
Thermal mass, right? That was the old get a bunch of dirt and tires and put those in your house, and then you'll have this big thermal bank that you can. Right? Yeah, that was. Well, I'm familiar with that. That was the 70s, right? That was the whole. That was the 70s. Vibe. Yeah.
Late 70s.
But you mentioned as well, you said you mentioned Dick Smith, who's one of the most famous businessmen in Australia, that he was recently on television talking about these things, and that he's become, he just blasted the Australian energy market operator, saying that they were lying, that wind and solar are cheaper than coal. And he said, because of that lie, and it's a lie, we're going to delay moving to nuclear. So how important is that? Because, I think about public perception, who goes on TV, right? That in the U.S. for a long period, there was a guy named T. Boone Pickens who was from Oklahoma, Holdenville, Oklahoma. And he would be on TV and he would kind of talk about the oil and gas industry and being in a very robust way. And he was an advocate. But we don't have in the United States still, I think, anyone who's identifiable as the leading voice for nuclear, particularly someone from industry. So how important is it someone like Dick Smith, who's one of your most recognizable businessmen, to be speaking so publicly about this in a way that's irreverent toward, calling out the AEMO and saying, well, they're a bunch of liars. How important is that?
Yeah, I think it's very important. I mean, Dick is a sort of an entrepreneur and an adventurer and a businessman. I think he was the first person to fly solo around the world in a helicopter, and he's done 5 aerial circumnavigations, and he's done all sorts of interesting things. And he's a serious environmentalist. But he founded Australian Geographic magazine. He supported the protest against the Franklin Dam in Tasmania. Dick really he's a Boy Scout. He's a Rover Scout. He's been out in the bush and the environment and loves the environment all his life. And
made his fortune mainly in retail, did he not? Is that in retail?
He had an So in the early days of electronics, when home hobbyist electronics and all that sort of thing was big, he made money there. And he also I think with car radios, cars didn't you used to buy a car. The standard car didn't have a radio. He used to provide car radios and sound systems.
Right.
Yeah. So Dick's sort of been in all those sorts of areas, and everyone in Australia recognises him.
Sure.
And for a long time, he's been of the view, very long time, that nuclear energy, is good technology and it has a place in our energy systems. And so I think, people who are, respected and recognised saying these things is actually quite important.
Well, so let's talk about mining, excuse me, more generally in Australia. There's a lot of talk about transition metals, and I've been writing about it. I lecture about it. I haven't written much about it yet, but this idea of the energy transition, and I look around and I look at the numbers and I say, what energy transition? I don't see any evidence that there's an energy transition, which takes us back to the coal business. But mining is a huge industry in Australia. How is the country capable of producing the quantities of copper, rare earth elements, the other things that will be needed, cobalt, other minerals that are going to be needed at scale to get to support a significant move toward more alternative energy? Where is Australia in that regard these days?
Yeah, so the mining industry is huge.
Yes.
It's the single biggest, source of export income for the country. It's very, very important to the country. And the mining sector here is, technologically advanced and sophisticated and all those things. Definitely, if you're going to go away from, mining hydrocarbons to using renewables, you just need to mine other things, and you need to mine huge amounts of those sort of materials that you mentioned. So in a kind of scenario where the world goes really big time in that direction, I think the general view is Australia would prosper. We're blessed with an abundance of lots of different minerals,
right?
And we would probably prosper from that. Whether the the income that we would earn from all those little things would outweigh the loss of coal and gas exports is an interesting question. Not sure about that. But can Australia supply the whole world's needs for those minerals? I don't think so. But we'd be part of the game.
Right.
Would we be as probably the key question would we be as well off? Would depend on the margin, the price versus the cost for Australian production. You see, one of the reasons we're so well off here, Robert, is because the natural resource rent in the big commodities we export is very large. So the cost of mining iron ore in the Pilbara is very low, and the international price is very high. Most of which is driven by Chinese demand. Right. It's not quite as extreme in the case of coal and gas, but the margins are still suitably attractive. So could we command those same sort of margins on all those other commodities collectively to make up? I think is an open question. Depends on a lot of complexity.
Well, and you'd have the issue of processing, right? And China dominates processing for rare earths, the lanthanides, and so on. So you would have to move further. There'd have to be a lot of investment in the downstream, right? If you're going to capture a lot of that value, no?
So this is a very important point you raise here, and it relates to some of our earlier conversation today. Which is that, so the processing is energy intensive. But the other thing to keep in mind is that traditionally the Australian mining sector, the big mining companies, have not tended to like the idea of being forced by the government to do processing onshore here in Australia. They prefer to focus on exporting the raw commodity where the margins are high, and then so a lot of the processing happens offshore. So that's why all the iron ore that goes to China, it's transformed to steel in China. So there's a large we make a lot of money on the raw material, but the steel mills in China struggle to and all compete with each other and make very small margins.
Right.
And then when you come to critical, which is one of the sources of tension in the relationship between Australia and China. And then when you come to critical minerals, as you've rightly said, the processing for those is both energy intensive and sort of toxic and challenging for the environment. And the processing of those minerals has become to be heavily concentrated in China. Now people are starting to think, well, hang on a minute, these minerals are critical not just for the energy transition, but for things like military applications.
Right.
And so there's a move to sort of onshore or reshore some of that processing in places like Australia. But we're just at the start of that journey. We're like barely out of the talking about it phase of that journey.
Yeah. Well, I think I don't think it is clear the U.S. is in the same situation. I mean, there's a lot of talk about this, but the Department of Energy put out a report, a very good one earlier this year. I believe it was something like 92% of the neodymium iron boron magnets, which are the high strength magnets for both EVs and for wind turbines, are produced in China. and that is a very large percentage. And then, so I can see why the producers, the miners, they don't want to get into processing because there's a lot of capital risk, there's technology risk, and there's political risk in terms of China, whether the Chinese processors will undercut their prices. I mean, so that brings the government back into play even more when it comes to those technologies and those commodities. No.
That's right. So, and there's a very strong echo in all this with our earlier conversation about electricity markets. The role of government and the planning versus the leave it to the market philosophy. Right. So the leave it to the market philosophy in minerals has resulted in an allocation of investment and production and processing that's been very driven by market forces.
Right.
And so that's why you tend to get this concentration in whichever place has got the cost advantage. So China has got these kind of strategic advantages, low labor costs, land costs, maybe environmental requirements are probably not as strict as they are in Australia or the US.
Sure.
Low cost of capital, all these things combined, give them an advantage. And so if the procurement officer in XYZ company, which might be the US military or it might be a wind turbine manufacturer, but if the procurement officer is just looking for the cheapest one, it's all going to end up being processed in China.
Right. Well, let me bounce back to the to the electricity system. Then what's the way that you address this then? Because we've identified fairly well the problems and the fact that nuclear and renewables are bad fit for the way these markets, I would say, have been restructured rather than deregulated. I don't know, this idea that they're somehow open markets or they're competitive markets. Well, yeah, kind of.
Not really.
So what's the proper role then? How does the government then? Because I think we're on the same page here in that there's a misapprehension about electricity in my view, that it's not a commodity, it's a service. And if you don't understand that, then you're just missing the point, right? This is the most important network and we can't allow it to fail. It's a service. Yes, we sell watt hours, but really we're selling power, and that power has to be there. So how does the government then, what does that proper structure look like? Should we be going back to the integrated monopoly electricity system that had dominated for decades? Is that the way to go?
That's the $64 billion question. That's the overarching question of the dual reform process that I was mentioning earlier. We're going to have to take a really hard look at how we do things in electricity, and then we're going to, in parallel, in Australia, we need to think about, the role of nuclear and things like that. And those conversations will have to run in parallel. So what's the role? The question is, what's the role of the government? What's the role of the private sector in this industry?
Right.
And how do we ensure that we get the security of supply that we need, and that we're getting the service. I love the way you use the word service. We're getting the service that's needed at a price that's competitive for businesses and affordable for households.
Right.
And then also that the environmental footprint or impact of all that is socially acceptable.
Right.
And that should obviously that's going to include the CO2 discussion, but it should not be limited to CO2. It should include all the other things as well, including land footprints and visual footprints and all the rest, right?
Right.
It all has to be considered holistically, and I think it's going to be very difficult to escape the fact that there's a role for planning and collective decision making involving government in all of that. That you can't just leave that whole thing to the market. I think that's just delusionary.
Yeah. Yeah, I think that hits it pretty well on the head. You can't leave the whole thing to the market, but therein lies the rub, right? That we've I think Australians in this sense are similar to the U.S. Well, we don't like monopolies, and so we're kind of reflexively against that. But my guest, I'm station break here, is my friend Stephen Wilson. We met in Australia some years ago. He's an adjunct professor at the University of Queensland. You can find him at the UQ website. You can find him on LinkedIn with this URL, au.linkedin.com/in/energy economist. Yeah, he's also at Cape Otway Associates. He's a consulting firm there. So, Stephen, we've been talking a while. I just want a couple of last questions on this. So, on these issues, handicap the energy situation around the world. We're in the midst, I think, of what is clearly a global energy crisis, both in terms of cost, reliability of supply. Which countries are better positioned now than others, and who's in the worst shape, who's in the best shape? I would limit it maybe to the OECD countries, because I think if we talk about the worst situation, we can obviously point to Sri Lanka or some of the other countries. But who has an advantage now as we look at the future, given all the challenges that we're facing global consumers?
That's a really great question, and I'm running through country lists in my mind, trying to think who's the standout, whose position would you rather be in?
Right.
And it's not obvious that there's any superstar country that's getting all this stuff right. It's really not obvious. Right. I think a country like Australia we have everything we need to do really well, but we need to get the decisions right. We're sort of our own worst enemy in a way. We've got to make really smart decisions, or we'll just end up with a worse and worse mess. But if we make the right decisions, we could be in a really, really good position. And I think the US could as well, and Canada could as well. Probably UK's natural advantages are probably not quite as strong in this as they don't have the big landmass and all the resources, but
they've got to start drilling. I mean, they just have to start, and they need to start yesterday. And I don't think there's any other way around it. But they still haven't repealed their frack ban. So,
they're getting things together on the nuclear front. They've realised that there's going to be a role for nuclear, for really good 21st century nuclear technology, and that they are in a very strong position to play a leading role. I think that penny has dropped in Westminster.
And it remains, well, and Rolls-Royce is talking a big game. We'll see if they can make it happen. So the last two questions, Stephen, because we've been talking now for more than an hour and I don't want to keep you. So what are you reading? What are the books that are on your top of your shelf or on the top of your desk there? What has captured your attention in the book world?
Oh, there's one that really grabbed my attention recently, which is called The Cloud Revolution by Mark P. Mills. I think anyone with a vague interest in energy or technology or the economy or the future of the 21st century investing should read that book. There's quite a bit about energy in there, and there's some good quirky trilemma type thinking in there as well. How the World Really Works by Smill. I've started reading that.
Right.
I realized that I was channeling him without realizing it back in February in my speech to the four societies. I asked the audience the question, which is more important, your brain or your heart, just as a thought provoker. And then he uses exactly that analogy, I think, in chapter 4 or something in that book.
Smill is amazing. I mean, incredibly
smart,
incredibly prolific and grumpy as well.
He's the grumpy old man club. He nails quite a few things, but the importance of system thinking is what comes through there. Yeah. So look up a guy called Russ Ackoff, Ackoff, I think it is. I think he's no longer with us, but there's a video on YouTube of him giving a talk, a 15-minute talk at a conference. I think that the YouTube tag might be if Russ Ackoff gave a TED talk, something like that. He explains in very clear terms the importance of system thinking. And he's not talking about power systems. He's looking at a different industry. He's actually looking at the automotive industry. But his explanation of the importance of system thinking is totally relevant to everything we've just been talking about today. So
that's
if you haven't got time for
ACKOFF.
I think so. I think I've got the spelling right. Yeah.
Well, that's interesting because I think you're right that we have to think more about the system as a system, and that has been lost. So, last question then, Stephen. What gives you hope? We've touched on a lot of things that are fairly sobering. I'll say, not depressing, but what as you look around and you look at the future, what makes you hopeful?
I woke up the other morning and I realized, I've never been in a political party, Robert. And fewer Australians are members of political parties. But I woke up the other morning and I realized I'm a member of the Common Sense Party. There's a lot of don't worry about talking to people in high places. You just talk to ordinary people, in the street and in the neighborhood and in daily life. And what you find is these people are way ahead of the elites. Like they really get this stuff.
Right.
And my next door neighbor, Bev, she's like in her late 80s or 90 or something like that. When I told her 3 years ago I was going to a meeting about nuclear, she said, "Oh, about time too." I thought, "Oh goodness," So there's, and then you talk to the 20-somethings, and the 20-something get this stuff. So, and then you talk to the tradies, the electricians, and these people. There's a lot of common sense out there. And I think the ordinary people are way ahead of the elites on all this stuff, to be honest. So that's what gives me hope.
Well, that's a good place to stop then. We'll do that right here. My guest has been Stephen Wilson. He's an adjunct professor at the University of Queensland. You can find him on LinkedIn. He's with Cape Otway Associates. He has many hats. And we've had a great discussion here. Stephen, thanks for being on the Power Hungry podcast. It's my pleasure, Robert. Thanks for inviting me. And thanks to all of you for tuning in. Tune in for the next episode. It might be as good as this one. We'll see. See ya. Cheers.